Welcome to a lesson with Dr. Powell. Let's take a look at another example of this boxing technique. Suppose we had f of x is equal to x to the sine x. Two different boxes. Let's take the derivative when this guy's the variable, and that's a constant. Well, it's just the power rule, so like x squared, let's think what we would do there. Minus 1, but the 2 out front. Do the same thing, but just replace 2 with the constant sine x. But we're not done because we only did this box. Now it's the other box's turn, and we add the result. So plus, okay, now that's the variable. So that x is like a constant. Replace it with like 2 and think about what's going to happen with this being the variable. Now we might have to do a chain type idea. Okay, so we think of the derivative of 2 to something. Well, isn't that, and we're thinking of, okay, 2 to something and thinking of the 2 as x here. Think of the 2 as x. Then wouldn't we get natural log x, so just like we'd have natural log 2, times x, which would be like 2 raised to something. So that would be like the derivative, right? But then we have to multiply on by what the derivative of sine is, which is cosine. So then, and what went up here was what we were plugging into this, which was just sine x. Now there's the derivative when we add the two together. There are other ways of doing this, but this is a very nice way of doing it, which is akin to the product rule, because it's really the boxing rule, which is more general than the product rule and is more applicable and can be used used all over the place. In fact, it can even be used for things as simple as x plus sine x, but it's kind of silly to use it that way, but you can. Just for instance, you have two boxes. You take the derivative with where this is the variable, that's a constant. Since you're adding a constant, the derivative of that's just 0. So the derivative of this is 1. Hey, you're done with making this the variable. Now go to make that the variable. That's a constant. So the derivative of that is 0. It's just the derivative of this, which is cosine. Isn't that just taking the derivative of each one individually? So we don't usually think of the boxing rule that time around, but it works all over the place and can be used in any situation. Thanks for watching.